To create our models, what we need to do is we need to have good data. If we're trying to take a bunch of data and make a guess out of it, we need to make sure that that data is clean, on the same scale, and relates to each other in an intelligent way. To do that, we have to usually take the data we have, the raw data, and clean it in one way or another. As you can see, we have these data. It has different scales on it. Some of it is coming in as text. There's nothing derived from any of this information, so it all doesn't relate to it. We're trying to take some form of these different, what we call features, put them together and guess, did this person pass or did this person not pass? We're trying to make a predictive model where we can put in any student in the future and guess if they pass or not. But if we have all this data all over the place, it will be almost impossible to form a model that makes any sort of sense. You can see that most of the data will come in like a JSON file, so we'll have giant sets of data that we need to then encode, we need to transform, we need to load it into different ways. That's what an ETL pipeline does, and it'll make our models way easier to generate, and it'll make them be a lot more accurate. So our first step is probably to tackle this income over here. Not only does it come in as text, but it comes in such a large number that it doesn't make sense with the rest of the data here. Just because there's a 45,000 here and a 4 here, it doesn't mean that there's 1,000 multiple between the two. So we need to make sure that we scale that appropriately so that it'll fit on a graph with the rest of this data. So by doing this, we can encode it into buckets. Because at the end of the day, we also have to think about the data itself. Does someone who earns $45,000 make a really big difference between someone who earns $45,000 and $10? No, not really. So we don't need to represent them that differently either. What we can do is we can actually take numbers like this and create broad categories or buckets. So in this particular case, we're essentially putting every 25,000 is a multiple of 1. So between 0 and 25,000 is a 1. Between 25,000 and 50,000 is a 2. 50,000 to 75 is a 3. We can then take all of this data and just bring them down to those numbers of 1, 2, or 3, or as you go bigger, 4, 5, 6, or change the buckets. This all is a little bit arbitrary, and we'll have to manipulate it just a little bit to make it make sense over time, but we start with something, we see if it makes sense, and then we can adjust it later on depending on what we think is happening. After income, we need to tackle these three. They are also on different scales. A GPA can only ever be maxed out at a 4, while study hours could be technically unlimited up to 1,000, 2,000, 10,000, depending on the range that we're looking at. And then our age. We have a lot of age here, just between 18 and about 25. We need to make a decision, does it make sense to have a scale that represents someone who could be 65, or is this really just a college and high school study? So we can adjust depending on that as well. What we're going to do is we're going to take all three of these and we're going to take them from being unscaled and we're going to scale them into a 0 to 1 range. So essentially we're taking this age on the left side and we're basically bringing it down to just between 0 or 18 and 24. Someone who's 24 is a 1, someone who's 18 is a 0, and that standardizes our age range. We're then going to take the GPA and do the exact same thing, where we're going to standardize it between 0 and 1 instead of between 0 and 4. And that will allow us to basically put these two on the same parameter. Our study hours as well, we're going to take that max value, which I believe was before this was 30, that's going to be 1, and then we're just going to scale everything from 0 to 30 into this 0 to 1 range. We can also take the income after we've sort of sorted them into buckets, and we can process them once more to put them into 0-1 range as well. So we've now done 2 levels of cleaning on this income. We've taken them out of that 0 to X million dollars and we put them into bucketed categories, and then we can take those bucketed categories and we can put them on a 0 to 1 scale as well. We have now taken our data and it is all normalized. We can take a relationship between age and study hours, or age and income, GPA and income, and it all sort of makes sense. It'll all fit on a graph nicely, and from that we can start making predictions. And finally, we can take this data and we can create other features from this data. So for example, we have age, GPA, and study. That's the raw data that came in. But we can come in and generate other features. For example, study efficiency. That could be this idea of GPA divided by study hours multiplied by 100. It measures the effectiveness of studying. We could split up the ages into just young and old. Instead of trying to figure out if 18 and 20 make any difference, we can say, is people beneath 21 or people above 21 have any statistical significance? We can also do things like squaring our GPA, and that'll capture nonlinear relationships by sort of bringing that information out. Really, data cleaning is a bit of a art form behind it. But we need to understand it as we go through and we build our models to see if our data is clean or if it's unclean, and if we need to make any adjustments as we go forward. At the end, though, we can just take what we've sort of generated, that sort of 0 to 1 standardization between age, GPA, study hours, and income, and we can utilize that as our now clean data set. We can input that into a graph of some sort and put it into an algorithm, and we can start making guesses by seeing, did they pass, did they not pass, and tune some sort of line or model to this. And from a coding perspective, we can sort of create this pipeline where we have the data coming in, we handle any missing data, any raw data, we encode the different categories, we then scale the different features to go to 0 to 1, and then we create new features, which is that idea of, generating a study efficiency or something like that, and then we return the data. So this can be a pipeline that you generate that takes all the data that we get, cleans it all up, and then allows it to be ready for the next phase when we're actually taking it and running it through different models. Thanks everyone for joining me on this next step in our AI development on data preparation and feature engineering, and we'll continue working on getting ourselves into building actual AI models. If you enjoyed this video and you want to see more in this series, go ahead and hit that subscribe button. I'm making videos that we're going to basically cover us from the very beginning to actually generating our own models at the end. So thanks everyone, and until next time, see ya.